It's the top of the hour. Let's get started. Hello, my name is Daniel Nenny, and I'm the founder of SemiWiki.com, the open forum for semiconductor professionals. Since going online in 2011, SemiWiki has registered more than 300,000 members. If you're not a member of the SemiWiki community, please register as my guest. Hope to see you there. The title of the webinar today is CPX, Leveraging CPC CPO for the latest scale-up and scale-out AI system technologies. The speaker today is Matthew Burns. Matt develops go-to-market strategies for Samtec's silicon-to-silicon solutions. Over the course of 25 years, he has been a leader in design, applications engineering, technical sales, and marketing in the telecommunications, medical, and electronic components industry. He currently serves as the secretary of PICMG. If you have questions, please put them in the chat box. This is a live webinar, so we will answer them during the Q&A. Okay, let's get started. Over to you, Matt.
Dan, thanks for the great setup. And so lots of interesting conversations, lots of interest in a lot of the tech trade shows we've seen over the last 4 to 6 weeks. AI Infra, ECOC, OCP was last week. We got supercomputing come up. A lot of interest in the industry about how to route AI infrastructure and how you route data from, one CPU to an XPU to thousands of XPUs. So really, the focus of our webinar today is to show how CPX technology helps with scale up and scale out for AI infrastructure. Before we get too deep into that, I just want to give a 30-second introduction to Samtec. For those of you that may not be aware of us, Samtec's been in business for roughly almost 50 years. We're headquartered here in the U.S. in New Albany, Indiana. That's right outside of Louisville, Kentucky. We focus on providing high-performance, high-speed interconnect for a variety of industries. If you look at the bottom right-hand slide, you'll see that we focus in on 8 core industries, mainly high-tech, computer semiconductor, industrial, medical, datacom, aerospace and defense, instrumentation, and automotive and transportation. AI, we tend to focus in on the computer semiconductor, but we know it's pervasive in so many industries. Samtec's founding is focused on customer service. We've coined the term sudden service, providing the solutions that our customers need in an equitable fashion that's equitable for them and for us. And we try to back that up with a global supply chain, either directly or through our sales partners or distribution to bring those solutions to markets as quickly as possible. When we look at a lot of the technology trends that we see in the industry, obviously everyone is worth the zeitgeist with AI ML, but even though that's pervasive in so many areas of our life, especially in infrastructure that we're going to talk about here in just a minute, we still see other emerging technology trends: 6G, high performance computing, electrification of vehicles, both in content and also from a power source. And when you look at all these trends, what this means is for interconnect, smaller, denser, faster. So for decades on the technology history roadmap, if you will, interconnect sort of trailed semiconductor performance. And often, early in my career as a design engineer, would design the semiconductor, and then, hey, I need a connector at the end. Let's figure out how to put it on. But now, just due to AI and several of these other high technology trends, interconnect is becoming an essential component, an essential architectural piece of architectural systems, specifically for AI infrastructure, which we're going to get into in more detail. We think about infrastructure from AI. I used this slide at a technology presentation I gave in Silicon Valley within the last month, and anytime I give a presentation, I always like to start off with just enough caffeine to make me interested and just focused on the presentation. Sometimes you need to double in the morning if you can't wake up. Maybe that's not the best analogy, but to me, I see a parallel there that AI infrastructure, whether it's the model size, the data rate, the data volume, it's doubling faster and faster. We used to be able to measure it in years, now it's in months. And I just one data point to show how AI infrastructure is evolving so quickly. PCI 7 was just released this past summer. It's 128 gigabit per second PAM4 technology, and already just 2 or 3 months ago, PCI SIG launched that they're starting their work on PCI 8. which gets us up to 256 gigabit per second per lane. So it's kind of mind-numbing to me how fast things evolve, but the industry is evolving at rapid pace, and interconnect industry has to keep up. I've been paying attention to AI infrastructure probably since about 2017, 2018. And when we first started, and when this first started to become a growing ecosystem that's become to today, AI acceleration was a simple thing. You have a CPU, you put a GPU on it, and as systems needed to scale in terms of adding additional AI capabilities, as the models were scaling, it was just a matter of how many GPUs could you attach to that same CPU. So it was very practical, coming out of the pandemic, to have, say, 4 GPUs or XPUs attached to a single CPU. You could use industry standard infrastructure such as a PCIe ChemAIC card that attached to a motherboard. Those cards are big enough, full scale, to handle 4 XPUs on it. Now that you look at modern, bleeding edge AI infrastructure ecosystems, it's not scaling a handful of GPUs or scaling a handful of XPUs on a single PCB. It's, depending upon the architecture of the system, it's tens, hundreds, thousands, even millions of GPUs within a system. So when you start to look at the interconnect, just the evolution on this very simple slide shows that, 1 CPU to 1 GPU, you can handle that with basic PCB traces. As data rates get faster, obviously you have to worry about locate dielectrics, trace lengths, and things like that from a signal integrity standpoint. Moving to 1 to N CPUs to GPUs, maybe it's the same computer motherboard with multiple PCI expansion slots, and instead of just relying on the PCI Express bus, you can tie those cards together with top card connectivity. And you use a combination of PCB traces and copper cabling. When it comes to scaling XPUs today, again, if it's tens or hundreds, there's the opportunity to use copper cable interconnect. But if you're scaling hundreds, thousands, tens of thousands of GPUs that are defining modern AI data centers, there's no doubt that fiber optics have to enter there. Rack scale can handle some copper fiber, which we'll talk about. But when you're talking about rows upon rows upon rows of AI XPU infrastructure, fiber optics are there, because the connectivity between the units are not measured in single meters, but in tens of meters, if not hundreds of meters. So, that kind of brings up what Samtec thinks about scale up, scale out conundrum. We're talking about copper cabling, we're talking about optics. There's so many different solutions from an interconnect standpoint that AI acceleration manufacturers or system integrators can make. What architecture technology will the end customer use? Whether that's a hyperscaler or some of the emerging use cases for smaller targeted GPU solution or AI infrastructure. In addition to scaling the XPUs, where do we route that data from the XPU on the system? Is that the front panel to the backplane? Again, based on our use case, is it co-packaged copper? Is it co-packaged optics? Is it near package optics? CPC, CPO, or NPO? Something that we're also seeing emerge over the last 6 to 12 months is, Samtec has long history using VCSEL technology for our optical interconnects, but there's emerging technology, tried and true technology from an optics standpoint. Do we look at silicon photonics? Do we look at micro LEDs, terahertz waveguides? There's newer versions with LPO or DSP for retimers to help make sure that the system data is synced and jitter and phase are minimized. So lots of questions that have to go into creating AI infrastructure when it comes to copper versus optical interconnect. And the question comes up is there a way to simplify that from an OEM standpoint so that I don't have to change my interconnect from platform to platform? Or if I'm a hyperscaler and I want to use XPU 1 versus XPU 2, whoever those may be, is there a way to scale or go from one platform to another with standard interconnect? Samtec's solution is, or answer to that question is yes. We think we can do it. We know we can do it. We've been doing it. with our customer base already. And that's really manifested by our 224 gigabit per second interconnect technology. We're going to spend the majority of our presentation today talking about our Sci-Fly HD solution, which has both co-packaged and near chip copper and optical solutions. And then we can route that to the front panel using OSFP technology, standard MSAs that are available widespread across the industry at 224. And then we'll talk about some of the backplane technology that we have for pursuing cabled backplane solutions, first from a copper standpoint, and then in an emerging, from an emerging viewpoint, optical. So going to co-packaged, going to Sci-Fly solution, we have two paths that we're pursuing. And, the question comes up, why would we want to pursue both co-packaged and or near chip? And it really gets down to system density, or the amount of differential pairs that are being routed within a system. While we're talking about AI infrastructure, you still need networking to tie multiple nodes together, whether that's there's any number of protocols out there. We're not here to take a stand on whether it's Ethernet or NVLink or UAL or eSUN or PCI Express or CXL. Each of those serve their purpose for their specific application. But at the chipset level, let's just use Ethernet just because it's so popular. If I want to route a 100 terabit switch, the latest ASICs for Ethernet networking have 1024 differential pairs. And getting those routed out in a dense system is a challenge. Samtec's solution, our Sci-Fly co-packaged solution, Punchline, allows you to route 1024 pairs on a single substrate that's the size of 95 millimeter by 95 millimeter package. That's the densest solution in the industry. And as we go through the presentation, you'll see why we can back that up and why we can say that. On the other hand, if an OEM wants to stay away from co-packaged solutions, but they still want to route that density, our near chip solutions allow for a smaller package, smaller substrate for the ASIC on a 90 millimeter by 90 millimeter package. But by using our near chip technology, we can still route those 1024 pairs in a area that's about 115 to 120 millimeter by millimeter square package. So both solutions are extremely dense. Obviously, the co-packaged solutions offer the industry's highest density solution for 1024 differential pairs. Something else that we also keep in mind, looking at why Samtec provides both CPC and NCC, co-packaged copper and near chip copper, are the system topologies that they allow. Looking at CPC to front panel, that can support 64 OSFPs and a 2RU front panel. You can connect some, if not all, to CPC. The advantages of that system architecture, low power, low cost LPO on the optic side, and an external 1 meter DAC. Looking at CPC to backplane, a little bit more density, 512 lanes in a 1RU solution, passive scale up, which allows 2 meter external cables. Some of the advantages, low cost, also very high density to 1RU backplane versus a 2RU front panel. NCC, which is also shown here, front panel is definitely going to be optic, 64 OSFPs or 512 lanes to the front panel. Connect all the OSFPs to NCC. Using this type of architecture, eliminates the need for retimers or exotic PCB materials, which lower system cost. There's a lot of data that we're summarizing with those use cases, but we're more than happy to support answer those questions more in detail offline for application-specific solutions. Another question that we get from a lot of our customers or potential customers or partners is, how in the world is Samtec making a co-packaged interconnect that supports both copper and optics? And this slide is really intended to try to answer that question. We make a surface mount mezzanine, a surface mount connector that attaches directly to an HDI substrate. You apply the ASIC die on that same substrate. Again, we're agnostic in terms of what that chip technology may be. That could be networking, that could be AI acceleration, it could be FPGA, it could be CPU. in any case, it's working with an OSAT, taking that surface mount connector, as many as you need for for as many as the high-speed differential pairs that you have to route off the system to the substrate. We add a stiffening support ring that helps with keeping the connectors aligned, as well as ensuring coplanarity of the substrate. The support ring also acts as a mating interface for mechanical support for any thermal mitigation solutions that you may use. Obviously, you have to apply a TIM to the top of the die, and then design the thermal mitigation solution for an application-specific solution. Customers we've worked with, we've seen convection cooling, we've seen conduction cooling, we've seen cold plate, we've seen liquid cooling. You know, the image here shows how you could use liquid cooling on, you know, in conjunction with our solution very efficiently, very quickly. We've designed the Sci-Fly HD connector to be very rugged for these type of applications. We're targeting industry standard SA305 solders, but we're also looking at other low temp solutions as well. A question that we get is, are we using standard BGA technology? We're using a non-solder ball design on the bottom of the connector. We find that improves uniformity, repeatability, and coplanarity on the system. And the stiffener, you know, the design of the stiffener, the solder, and the assembly process is all based in collaboration with our partner and, you know, the OSAT that they're most comfortable with. This gives this illustration is a marketing mock-up of an actual application that we designed with a major networking chipset provider, which we'll talk about here in just a moment. But you can see the surface mount connectors attached to the HDI substrate, the ASIC from the OEM. We have the entire substrate with the connectors, the stiffener, and the ASIC applied to the host PCB using standard surface mount packages. Obviously, these connectors are designed to connect to Samtec's co-packaged copper solutions. So Samtec is the industry leader when it comes to performance of twin-ax cabling. We'll talk about that here in just a moment. But for Sci-Fly HD, we offer ultra-high density co-packaged substrates to cable. What's nice about our solution, since we're using surface mount technology instead of compression mount, there's no external hardware required for retention. The high density interconnect supports 224. We're working on a 448. We'll talk about that here more in just a moment. And from a cable standpoint, we're looking at 32 gauge hyper-low skew twin-ax solutions as well. The 64 differential pair connector that we offer as standard for Sci-Fly HD is very thin. So you can see that it's roughly 17 millimeter by 15 millimeter in, looking inward, and the Z direction is roughly 18 millimeters tall. What that allows for in the primary implementation of Sci-Fly HD so far is roughly 6.4 terabit per second aggregate, supporting 200 G per lane in a very small package. Samtec flyover cable technology. Samtec's again, the reason that we offer the industry-leading performance in our solution here is because of the co-extrusion techniques that we have perfected for our cable manufacturing. You can see a cross-section of the cable there. It's copper plated with silver, pulled through a low decay dielectric material. We coat it with copper braiding for grounding, some silver braiding for additional grounding and ruggedization of the cable, and then we add a protective cable cover using advanced plastic technologies. This manufacturing scheme allows us to get hyper-low skew of 1.75 picosecond per meter max intra-pair along our cable. We also offer optimal flexibility for our cable assembly solutions. There's 32 gauge that offers better SI performance inside the box. We use a 28 gauge outside the box for additional flexibility. All of our solutions at 224 are commercially available, and we're working on 448 solutions, which will detail, as we get closer or into 26. graph on the right-hand side also shows the smooth loss of the cable. This is 1 meter data, 32 gauge versus 34 gauge, out to 60 gigahertz. So, 224 PAM4, Nyquist at 56. You see, industry-leading loss profiles and also smooth performance over frequency range. In addition to the cable technology, we mentioned earlier about how Sci-Fly, we've developed backplane technology for copper backplane solutions, and we also have flyover versions of OSFP, 1x1, 1x2, 1x4, and then also belly-to-belly solutions that we're working on there as well. A little bit more detail about Sci-Fly HD backplane connectivity, since we've seen a lot of interest in that. This supports high density in a 1RU application. Just using the interconnect with guidance, we can get 1,792 differential pairs, or if you don't use the guidance hardware, we can get up to 2,048 differential pairs with gang connectors. We also support additional features, blind mating, without external mechanism or pressure. Showing this high density capability, there are images of a proof of concept that we worked on with Marvell. We'll talk about that here more in just a moment. So, questions come up, say, okay, Samtech, you're claiming that you got 224 performance. What proof in the pudding do you have to show that? We're going to talk just briefly about 3 use cases where we've done proof of concept demonstration at trade shows over the last 6 to 9 months. In this particular instance, we worked with Synopsys on their 224G long range, I think it was their Ethernet PHY, transmitting 32-bit PRBS of 224 PAM4 data, 224 gigabit per second PAM4 data. You can see the Synopsys test chip solution on the upper left-hand side of the illustration. The data routes from that chipset through our high-performance RF system to a test board for our Sci-Fly NCC cable. The entire system is about 2 meters long if you go from pad to pad. The entire channel has roughly 40 dBs of loss at 56 gigahertz. We ran 224 gigabit per second PAM4 data using the Synopsys tool, and we saw a prefect BER of about 3e to the -9. The first time we ran this system was at supercomputing almost a year ago, and we continue to work on expanding or improving the performance of the SI on the NCC cables. Another demonstration that we developed around our co-packaged copper Sci-Fly solution was a 200G short-range demonstration with Broadcom. This combined Samtech Sci-Fly HD CPC with Broadcom's 200G SerDes. We first showed this demonstration platform at DesignCon earlier this year. In this use case, we route the signal routes 30 millimeters from the Broadcom ASIC to the Sci-Fly service mount connector on the substrate, and there's about a 150 millimeter loopback using our low skew twin-ax. You can see that right there in the center, integrated within the heatsink for the solution. The total channel loss for this system is roughly 20 dB at 53 gigahertz, and we produced a BER of about 9.3 e to the -13 prefect error-free. This type of use case could have immense potential on chip-to-chip connectivity and several AI infrastructure implementations. More recently, we also work with Broadcom to create a long-range 200G CPC demonstration platform. The signal path is the Broadcom SerDes to our interconnect. You can see we have 250 millimeter of flyover cable routing to a Samtech OSFP front panel connector. There's a 1.5 millimeter passive DAC, another 250 millimeter of flyover cable routing back to the Broadcom SerDes. So the entire channel is roughly 2 meters in length of passive copper. Total channel loss is roughly 48 dB at 53 gigahertz. The first time we ran this with Broadcom at DesignCon, we had one lane running roughly 1.6 e to the -9 BER. And then we just reran the system after some, working with Broadcom to work some bugs out of the system, fully maximizing the performance of the 224G MSA OSFP cage that we have on the system. And we're now running 3 lanes at 3E the -11. So, this more than exceeds the signal integrity requirements for 200G protocols for front panel use cases. Lastly, we alluded to the density potential that Sci-Fly CPC has in scale-up architectures, mentioning some work we did with Marvell. This is an image of an actual system that we built with Marvell. You can see that we have CPC with the backplane going from the ASIC die to the connector on the substrate and then back to the backplane. This system, or the system design approach for scale-up architectures, offers more than 2x the density of a front panel approach. It also offers 2x the interconnect density within rack and allows for the lowest power consumption because it's all passive copper. This also provides a pathway for CPC to from 224 to 448 PAM4 in the same form factor. That's the design goal for Samtec when it comes to our CPX solutions. So far we've talked about, we've introduced the concept of CPC, and we've introduced the concept of CPO. When you look at the title of this webinar, it's CPX. So how does that tie together? This image really shows Samtec's Sci-Fly HD co-packaged connectivity, where the same surface mount connector that lies on the substrate that's routing copper cable is also interchangeable with a pluggable optics module, enabling easy transition from copper to optics to allow any system architecture, whether it's scale up or scale out, at 224 with a pathway to 448. Just a little more detail about our CPX interconnect solution. The heart of it is what we've been talking about, our CPX socket that accepts both the CPC and the CPO. As we mentioned earlier, this can support roughly 6.4 terabit per second in a 15 millimeter by roughly 17 millimeter solution that, as we've also mentioned earlier, is soldered directly to the substrate package by an OSAT. That same CPX, we also offer a CPX mezzanine, which would be soldered to the bottom side of an optical engine substrate. You can see that shown in the diagram of the bottom right-hand standpoint. And then the entire optical transceiver is electrically detachable, similar to a front panel pluggable. So the way I like to think of it is, if you can see my mouse, here's the system ASIC, again, AI accelerator, networking IC, whatever the case may be. The package substrate, this CPX connector can handle copper, which we show here, or optics, as we show here. We have a mezzanine connector, we have an optical substrate, we have an optical engine that sits on top of that optical substrate, and the fiber optics would attach directly to the optical engine, making a front panel pluggable solution. What does that look like in a little bit more detail? Samtec has created a CPX manufacturing spec or design spec that enables the OEM to leverage the full scale flexibility that Samtec CPX offers. One of the questions we get is, how do you handle the power and control lines that are necessary to enable optical engines? And we've come up with 3 options or configurations that an OEM can use to get power and control lines from the ASIC to the optical engine. One is we've created a power control connector that can attach directly to the substrate and bring those signals from the ASIC up through the secondary connector, mezzanine on the optical engine substrate, and then directly into the optical engine itself. This power and control connector can attach either directly to the ASIC substrate or the main board within a system. We've also had OEMs ask us if we can put power and control in the CPX socket, and that's also a third option that we provide as well. This graphic illustration shows that we've allowed for integrated thermal relief Again, whether someone uses convection, conduction, a cold plate, liquid cooling, that's really up to them. And then the optical engine technology used here is defined by the OEM or the Samtec partner. We are working on expanding our ecosystem of optical engine providers, specifically for the Sci-Fly platform. The first customer or the first partner that we've publicly mentioned that we're working on combining optical engine technology with Samtec Sci-Fly platform is Nubis Technologies. Nubis was recently purchased by Ciena. So that the Ciena purchase of Nubis validates the technologies that they've been working on specifically for AI infrastructure scale up and scale out, and we're excited to work with them. We're working with other partners that will publicly announce early in 2026 with the goal of being able to announce those at DesignCon 2026 in the February timeframe. Just a little bit more detail about how Sci-Fly HD CPX compares to alternative CPO solutions. We haven't seen any other platform in the industry that supports both CPO and CPC with the same interconnect. So that is a unique differentiation that Samtec offers. As such, we offer electrically detachable and optically detachable solutions. We offer the industry's highest density at being able to run 100 terabit per second system, terabyte system in a 95 millimeter by 95 millimeter solution. Because we're using surface mount technology both on the substrate and also attaching the substrate to the PCB, we have near 100% yield. We haven't been able to see those results with alternative CPO infrastructures as of yet. The complexity of our system is straightforward and low versus some of the more advanced techniques that are required for alternative CPO solutions. And from an ecosystem standpoint, when it comes to optical engine technology providers, we want to make it as simple as front panel pluggable, whereas alternative CPOs will require OSATs to build the optical solution. Another question that we get is, how is Samtec going to handle high volume? Is this a single source solution? One of the strategies that we've used to address that concern is the fact that we have second sourced our Sci-Fly HD technology with Molex. Both Samtec and Molex have a long history of dual sourcing options. We typically focus on targeted solutions for key applications. This is not the first time that Samtec and Molex have entered into second source agreements. So we have a long history of cooperating as partners in key areas. And for additional details on the second source specific to Sci-Fly, would point you to the September 9th, 2025 press release that Samtec and Molex jointly released detailing our partnership on this technology. So wrapping up, key advantages of Samtec CPX technology. The same interconnects system supports copper twin acts or any type of optical engine technology, including silicon photonics, terahertz waveguide, micro LED, HPIC, and more. We've talked earlier about how Samtec has the industry leading system density with the ability to route 102 terabit system networking switch from a 95 millimeter by 95 millimeter package. That also gives us SI advantages over compression technology that we see across the industry. Sci-Fly HD also features low external retention forces, whether that's for copper or for optics, but having those low retention forces makes Samtec CPX ideally suited for the CPO solutions that many are interested, especially for AI infrastructure. We've also seen that Sci-Fly is stable over temperature, and most importantly, Sci-Fly HD is scalable from the current 200G technology that we see to the 400G technology that everyone is interested in. So we are actively working on 448 PAMX solutions under the Sci-Fly banner, and we expect to be able to announce more details around that with the goal of doing that at DesignCon next year. Our 448 versions of Sci-Fly will enable 400 terabit per second system in a 1OU chassis. As we mentioned, we're expanding our ecosystem of optical engine providers. Nubis is our first. We'll look to announce further partners early in 26. And we're also working to expand on the second source solution that we have with Molex around Sci-Fly HD to early planning stages for an MSA around this technology. Solutions are available now, and you can visit our website for the latest details. Dan, I'm going to turn it back to you. So if the audience has any Q&A, we can try to answer those as best we can.
Thanks, Matt. Great presentation. Yeah, there are some questions. So first question, what's the maturity of micro LED for optical communications? Can you share anything with potential partners, vendors?
So great question. We don't have any, I mentioned earlier that we're working with Nubis, so I can't share any other details, or we're not ready to share any details on additional partners, but we are aware of micro LED technology. Some of the partners that we're working with are pursuing that from an optical engine solution. Again, Samtech, the conversations I've had with potential partners, potential customers at trade shows over the last couple months, have brought this question up a lot. And the way I would like to answer that for those listening in is Samtech is not trying to be a pluggable optical transceiver company. We're trying to provide the infrastructure for the optical interconnects that any OEM may want. Some of our current mid-board optical engine solutions are VCSEL based. We're looking, we've worked with silicon photonics options. We've worked with HPIC options there, and that history of using different optical transceiver technology, we want to transport over to Sci-Fly HD. So just stay tuned to our website or contact us directly, and we'll provide additional detail on optical engine technology as we move into 2026. But great question.
Does Samtech offer second sourcing on Sci-Fly HD?
Yeah, that's a good question, and hopefully we answered that briefly with the fact that we signed the second source agreement with Molex on Sci-Fly HD technology 6 weeks ago. We're having active ongoing conversations with Molex to understand their ramp up from a manufacturing standpoint. So, anyone that's interested in learning the latest can contact Samtech or Molex directly on that topic.
Is Sci-Fly HD a part of an MSA? Are there any plans there?
Yes, the short answer is yes. We're not there yet, but we're in the planning stages of wanting to make that available in the near term.
Can you detail the type of optical engine supported on the Sci-Fly HD CPO engine or option? Yeah,
so again, there's a lot of options that are available there on the market, Dan, and it's good to see that the attendees and those that are listening in are interested in a variety of solutions there. Whether it's VCSEL based, whether it's SiPho based, whether it's micro LED based, whether it's terahertz waveguide, whether it requires retimers or it's LPO or it's more of a DSP based solution. Our thought process at Samtech is we're really optical engine technology agnostic in terms of what our OEM partners or our optical engine partners provide. We just want to provide the infrastructure. So if there's any OEM that's listening and they have a preferential optical engine technology and we're not working with that a technology provider there, let's have conversations, right? CPO and NPO, definitely where AI infrastructure is going. We're open for business for partnerships. Samtech has a long history of working with technology partners across the spectrum, and if any OEM has a specific optical engine technology they want to work with, we're happy to work with. We're happy to engage with them and their optical transceiver provider to come up with a solution that makes sense for both CPC and CPO.
Okay. Is there a 448 Gbps or 448 gigabit per second PAM4 version of Sci-Fly HD in the works?
The short answer is yes. We'll be able to announce more details on that early in 26. As a side note, it was encouraging to see, we were just at the OCP Global Summit last week in San Jose in Silicon Valley. And it was good to see real, without naming names, it was good to see real 448 technology on the floor there. There's at least 3 providers I saw that had 448 solutions. So, the technology is real, it's coming, and it's just a matter of finding the right, if I'm an OEM or if I'm a hyperscaler, it's just trying to find the right infrastructure or the right application that makes the most sense for your use case.
Okay, we have one final question. We're almost out of time. Sci-Fly HD CPC NCC works at 224 gigabits per second PAM4. What does it route to on the front panel or backplane?
Yeah, great question. So right now on the front panel, it's OSFP technology. So we use standard 224 gigabit per second PAM4 OSFP cages as defined by the various MSAs. And then as Samtec always has, we use our Samtec flyover technology, direct connect the differential pair to the card edge connector of the contact within the OSFP cage, and that eliminates the need for routing signals down to the PCB and gets it from the OSFP transceiver to the card edge to the cable and routes it to the system ASIC using Sci-Fly HD for the most optimized signal integrity path. On the backplane, right now, we're focused in on Sci-Fly HD backplane technology that we've illustrated throughout the webinar so far, but we're also looking at other options for other commercially available 224 backplane technology as well too. So stay tuned for more information from Samtec on that topic, and if you need additional details or need additional depth on that, you can contact us directly and we can share additional details.
Thank you, Matt. Great conversation. And thank you everyone for participating in the SemiWiki webinar series, and have a great day.
Thanks, Dan. Thanks for our listeners.